This is Pre-Algebra, Lesson 11-5, Direct Variation. Our definition says here, for direct variation, two variable quantities are related proportionally by a constant positive ratio. Well, that makes a lot of sense, doesn't it? The ratio is called the constant of proportionality. Here's what you need to know. This form right here, y equals kx, is the form for direct variation. Another form of that is helpful is k equals y over x. And I want you to realize that if you know y equals kx, you can derive this from it by trying to get k by itself. Divide both sides by x, and you have y over x equals k, or k equals y over x. This form of it is useful when you are trying to find k, because k has been solved for here. And I know you don't understand yet, but just keep paying attention and you'll get it. Here is a helpful hint. If you were to graph a direct variation equation, it always makes a straight line, so it's linear, and it always contains the point 0, 0. The variables x and y, they either increase together or they decrease together. So if x is going up, y is going up. If x is going down, y is going down. So they act together. Here's a very simple real-life situation. Let's say you make $5 an hour to babysit. That's the direct variation equation for this. If you were to graph it, if you work 0 hours, you get $0. So you're plugging in 0 here. And you see that 5 times 0 equals 0. So it does contain the point 0, 0. Let's say you work 1 hour, you make $5. You work 2 hours, you make $10. It makes a straight line when you graph it, and it contains the point 0, 0. That's all it is. So the more hours you babysit, the more money you make. This example says, determine whether the data set shows direct variation. So Adam's growth chart is what this is about, and how old Adam is in months. When he's 3 months old, he's 22 inches long. When he's 6 months old, he's 24 inches long, and so on and so forth. We should know that this is a ridiculous example for direct variation, because it's not going to contain the point 0, 0, because that would mean when Adam was born, he was 0 inches long, and we all know that that is not true. There are a couple other ways you can tell that this situation does not represent direct variation. For example, this number is going up by 3s. This number goes up by 2, and then 1, and then 2. So this is not constant, while this is constant. That's going up by 3s. So there's another way you can tell that it does not represent direct variation. If I had not figured out already that this does not represent direct variation, here's what I could do. We could figure out, take this number, we're going to call that y, and this x, and divide one by the other. So I'm going to do 22 divided by 3, and that equals 7.3 continuous. And then I'm going to do 24 divided by 6, and I know that's 4. And then I already have 2 that don't match. If they don't match, then the situation does not represent direct variation. If you were to plot those points from the chart on the previous slide, you would get this graph, and you can see that it is not linear. So that's another thing you can use to determine that it is not a direct variation situation. Here's one more thing you can do, although you'd have to, if your answer was yes, you would have to continue to compare fractions. So this was 22 inches at 3 months and 27 inches at 12 months. You can do their cross products, and if they are not equal, then it does not represent a direct variation situation. Okay, here's another chart with some different data. Let's understand it first of all. Distance traveled by train. So this is how long they traveled, and this is how far they traveled. So does it look like it could be direct variation? Would it contain the point 0, 0? I traveled 0 time, I went 0 distance. That makes sense. These are going up by 10s, and these are going up by 25s. So it looks pretty good so far. I would go ahead and use my calculator and do this division. 25 divided by 10 is 2.5. 50 divided by 20 is 2.5. 75 divided by 30 is 2.5. And 100 divided by 40 is 2.5. And if this right here works, if you do that division and they are all the same, then that does represent direct variation. Another thing that you could do is plot the graph, and you can see that it is indeed linear. The points line up, and we talked about the fact that it would contain the point 0, 0. So the title of this chart is Kyle's basketball shots. So it looks like he's shooting from farther and farther away, and the number of baskets that he makes. We should be able to tell, first of all, these numbers are going up and these numbers are going down. So that is absolutely not going to be a direct variation equation. And you can imagine the farther away from the basket you are, the fewer shots you're going to make. So this does not represent direct variation, just based simply upon the fact that one variable is going up while the other one is going down. This chart shows ounces in a cup. Clearly this is a constant thing. There are 8 ounces in 1 cup. 1 divided by 8 is 1/8. There are 2 ounces in 16 ounces in 2 cups. This was 8 ounces in 1 cup, 16 ounces in 2 cups. 2 divided by 16, 1/8, 1/8, and 1/8. If this right here is true, then it does represent a direct variation equation. Okay, this is a different kind of problem now. It says, find each equation of direct variation given that y varies directly with x. So here's what you need to do. Remember that the direct variation equation is y equals kx. Well, what did they give you? They gave you y and they gave you x. If we have 2 of the 3 things, we can solve for the third one. Do you remember at the beginning I told you that you could also use k equals y over x, that those are essentially the same thing. And since we're trying to solve for k, I would go ahead and use this. Our work will be less. Okay, so let's go ahead and plug in. We don't know k equals y is 54 and x is 6. We know that 54 over 6 is 9. All you need to write a direct variation equation is k. K stands for the constant of variation. In our original example about babysitting, it would be how much money you're making per hour. So you take that k and simply plug it into this. When they ask you to write a direct variation equation, this is the form it's going to take. Y equals some number times x. That's all. This is the exact same kind of problem. They gave you x and y. So let's use k equals y over x to find k. Plug in what we know. And k equals, let's just simplify that by dividing by 3 over 3. Gives us 5/4. So k equals 5/4. And just like with slope, we're going to leave that as an improper fraction. And in fact, if you think about it, that is the slope. Then if we know k, we just plug it into this to write the direct variation equation. So really, if they give you x and y, all you have to do is y divided by x, and then plug that number in there. That's all there is to it. By now, you might be good enough to do this. Oh, let's try that. Oh, no, that is what I want. Y equals 8/5 x. Do you see where I got that? I just did y divided by x and plugged it into that spot. If you need to write out all the work, that's fine. Remember, we had k equals y over x. Plug in y and x, and then plug that into this. But after you do that a few times, you ought to be able to just go directly to the answer. Sometimes you have to simplify a fraction or something. All right, here's a word problem for you. Mrs. Perez has $4,000 in a CD, that means certificate of deposit, and $4,000 in a money market account. The amount of interest she has earned since the beginning of the year is organized in the following table. Determine whether there is a direct variation between either of the data sets and time. If so, find the equation of direct variation. Go ahead and take a look at it. Do you see patterns in there? Okay, let's think of just this information. It's just like the charts at the beginning of the lesson, but turned on its side. Does it contain the point 0, 0? And as these go up by a constant amount, do these go up by a constant amount? These go up by 1s, and these are going up by 17s. Does it continue throughout? And the answer is yes. Every time you're adding 17. And guess what the equation for direct variation is? Y equals 17x. It's kind of like the babysitting situation again, only this time you're making $17 an hour. 1 hour, $17. 2 hours, $34. $17 per hour. What about the interest from the money market? So you're going to use the same time here, and that's the interest. So it still contains the point 0, 0. These are still going up by 1s. This goes up by 19, and then 18, and then, what is that, 18, and then 18. So it's almost direct variation, but not quite, because it is not going up consistently. Here's a little quiz for you to do. Pause the video and then turn it back on when you're ready for the answers.